Now we're at question 4. The circle C1 has equation x squared plus y squared minus 4x plus 2y minus 2 is equal to 0. And the circle C2 also have a common center with C1. So let's find the center of C1. And that will give us the center of C2, since both centers are the same. So for C1, we end up with x squared plus y squared. We can group the x's, so we have x squared minus 4x plus y squared plus 2y. And we can add 2 to both sides, so we have positive 2 over here. So we complete the square. So x minus half of the b value, which is minus 2, minus the square of this value, which is 4, plus y plus half of the b value, which is 1, minus the square of this value, which is 1, equal to 2. And if we add 5 to both sides, we end up with x minus 2 square plus y plus 1 square is equal to 7. Which means that center of C1 and also C2, we're told these circles have the same center. So the center is positive 2 and negative 1. Next, we are told that given that C2 passes through the point minus 1, minus 2, let's do a look at diagram here. So if we have a circle, and of course the center is 2, negative 1, and of course the circumference passes through the point minus 1, minus 2. So we connect the center to the circumference. That's the radius. So if we find the length of this line, it will give us the radius of C2. So radius we can use, so the radius is equal to square root, let's say x2 minus x1 square plus y2 minus y1 square. Let's put the diagram here again. Remember, 2, negative 1 is the center, and passes through the point minus 1, minus 2. So find the length of that line, which represents the radius. So we can call this x1, y1, x2, y2. So we end up with 2 minus minus 1, that's become 2 plus 1. And then minus 1 minus minus 2 is minus 1 plus 2 all square. So r is the square root 3 square, that's 9. 1, so the square root of 10. So which means r square is equal to 10. So it means therefore that the equation of C2 is, and we have, remember the center, so the equation would be x minus 2 all square plus y plus 1 square equal to r square, which is 10. Next, the equation of the line L1 is x plus 2y is equal to 3. Determine whether L1 is a tangent to the circle C1 in the page above. So we need to find the point of intersection. So we substitute L1. We can rewrite L1 as 3 minus 3y. We sub this into the equation of circle 1. the equation of circle 1, let's scroll up. The equation of circle 1 was, here it is, x squared plus y squared minus 4x plus 2y minus 2 is equal to 0. So we end up with 3 minus 3y all square. So this should be, so x is 3 minus 3y, so 3 minus 3y all square plus y square minus 4 times x, and remember x is 3 minus 3y plus 2y minus 2 is equal to 0. So expand, we get 9 minus 18y plus 9y square plus y square minus 12 plus 12y plus 2y minus 2 is equal to 0. So we're going to group like terms. So we end up with 10y square. Grouping the y, we have minus 18 plus 12, that's minus 6, and 2, that's 8y. And we have 9 minus 12, that's minus 3, minus 2, that's minus 5. Actually, there's an error here. There should be positive 4y. Notice negative 4y, sorry, minus 18 plus 12 plus 2. So we're going to solve. Cannot be factorized, so solve using the quadratic formula. So we end up with y using the formula minus b plus or minus b squared minus 4ac all upon 2a. So we end up with y is, well, so a is 10, b is minus 4, c is minus 5. So we end up with positive 4 plus or minus the square root of 4 squared, which would be 16, minus 4 times a times c, so it's minus 4 times a, which is 10, times c, which is minus 5. So that's 4 5s 20 times 10, that's positive 200 upon 2a. Now a is 10, so 2a will be 20. No, we don't need to go any further. So this is obvious. So right now let's look at we will end up getting 2 values for y, hence 2 values for x, which is telling us that the line cuts the circle twice, and therefore line cuts the circle 2 times. Line cuts the circle twice, which means that the line is not a tangent to the circle. Because if the line was a tangent to the circle, it would cut the circle only once. So you have a circle, so the line cut it twice, hence it cannot be a tangent. A tangent would look something like this, where you have a circle, and you have a line just touch it once on the circumference. Alright? But because this line intersects the circle twice, the line cannot be a tangent. Part B is a vectors question. So we have a point P, 3, 1, 2, and we have a point Q, 1, minus 2, 4. It's 3-dimensional. So we're asked to find the vector PQ. So the vector PQ, of course, would be Q minus P, which would be, the point Q is 1, minus 2, 4, and the point Q is 3, 1, 2. We subtract, we end up with minus 2, minus 3, and 4 minus 2 is positive 2. So in the form IJK, means therefore that PQ is equal to minus 2i minus 3j plus 2k. Determine the Cartesian equation of a plane which passes through the point Q and is perpendicular to the vector PQ. Now the Cartesian equation of a plane is given as Rn, R dot n, so the vector product equal to A dot n, where R is x, y, z, n is a normal vector, which is a vector perpendicular to PQ, which was minus 2, minus 3, positive 2, and A is a point in the plane, and we can use point Q, where the plane passes through point Q, and point Q was 1 minus 2, 4. Recall that point 2 was 1 minus 2, 4. And n, normal vector, minus 2, minus 3, positive 2. And of course, we're asked, it's okay to use minus 2, minus 3, 2, because this plane equation is perpendicular to PQ. Alright, so we end up with the vector product is minus 2x minus 3y plus 2z. That product for these over here, 1 minus 2, negative 2 times minus 3, that's positive 6, 4 times 2, that's 8. So we end up with minus 2x minus 3y plus 2z is equal to, this is what, 6 and 8, that's 14 minus 2, that's 12. Now we have two vector equations, L1 and L2, there they are, and we are asked to show that L1 and L2 intersect. So we're going to equate L1 and L2, let L1 be equal to L2, and let's see if we can find the point of intersection by equating coefficients of like terms. So L1, that's minus I plus j minus 2k plus alpha into minus 2i plus j minus 3k. And we equate this to L2, we get minus 2i plus j minus 4k plus beta into I minus j plus k. Next we can equate coefficients of I, j, and k. Now for the I, the coefficient of the I on the left hand side for the I is minus 1 minus 2 alpha now we can do some grouping here. This means that beta plus 2 alpha is equal to positive 1. So I can call that, box up that, that's an equation. Equate the coefficient for the j. On the left hand side we have 1 plus alpha. On the right hand side for j we have 1j minus beta, and we can fix this up. This means that alpha plus beta is equal to 0. Can get a third equation by equating coefficients for the k. On the left hand side, it's minus 2 and minus 3 alpha. And on the right hand side for k, it's minus 4 plus beta. So we end up with grouping 2 equal beta plus 3 alpha. So we have 3 pair of equations. We have a system of equations here with 3 equations, and we can solve simultaneously. Let me just group these 2 equations. We call this equation 1, equation 2, equation 3. So I'm going to subtract. Here's equation 2. 2 equal beta plus 3 alpha. And equation 1, 1 equal to beta plus 2 alpha. Now if I subtract, 2 minus 1, that's 1. Beta minus beta, that's 0. 3 alpha minus 2 alpha, that's 1. So alpha is equal to 1. We can substitute this value of alpha into any one of the equation. Let me substitute it into equation 2. Notice from equation 2, if alpha is 1, then 1 plus beta is equal to 0, which means therefore that beta would be equal to minus 1. And we can also get the value we can deduce now the point of intersection of the 2 vectors. So L1, let's recall that L1 was, remind ourselves of what L1 was. L1 was minus I, J, so L1. So recall that alpha was 1, and the value of beta was negative 1. So from here, L1 would be minus I plus J minus 2k plus, and we can expand now, alpha was 1, so it would be, if alpha is 1, it would be expand each term in the bracket by 1, we'll get minus 2i plus j minus 3k, and this would be the group the like term, that would be minus 3i plus 2j minus 5k. Let's try it for L2 and see if we get the same result. L2, remember L2 was minus 2i plus j minus 4k, and then remember the b is negative 1, so we're going to times each term in the bracket by a minus 1, so end up with minus I positive j minus k. For group like terms, we end up with minus 3i plus 2j minus 5k. Notice we get the same point, and this will be the point of intersection of the 2 vectors. So the point of intersection, you can put it up here, therefore a point of intersection of L1 and L2 would be minus 3, 2, and minus 5. Question 5. Determine the values of k for which this piecewise function is continuous. Now if this function is continuous, at say x equal 1, then x to the power of 5 minus 1 upon x minus 1 is equal to k when x equal to 1. Alright, let's factorize. Now you will recall that a to the power of 5, so in k is 5, the function is continuous for all values of x. Part B, find dy by dx. So dy by dx is dy by dt upon dx by dt. dy by dt is 3t squared minus 2t, and dx by dt, that's 5. Hence determine all points of C such that dy by dx is equal to 0. Now, we just found dy by dx to be, 3t squared minus 2t upon 5. So you equate that to 0 and solve. So we end up with 3t squared minus t is equal to 0. We factor t. So we have 3t minus 1 equal to 0. So t is equal to 0, or t is equal to, equate the bracket to 0. We get 3t minus 1 equals 0. So t is equal to 1/3. So, remember what the values of x and y were. Alright, so x was, I must write down the values down here. This is 3t squared minus 2t, so this would be minus 2. So 2/3. Alright, so notice when t is 0, x is equal to 3 and y is equal to 2. So the point is 3, 2. And when t is 2/3, put it over here. When t is 2/3, x is equal to 5 times 2/3 plus 3. Now 5 times 2/3, that's what? 10 over 3. 10 over 3 plus 9 over 3. That's 3. Take 3 is 9 over 3, right? That's 19 over 3. And the y would be t cubed. So 2/3 raised to the power of 3, that's 8 over 27. Minus 4 over 9 plus 2. We can make all the denominators be 27, so we end up with 8 minus 12 plus 54. So 8 minus 12, that's minus 4, that's 50 over 27. So hence the point here would be x is 9 over 3, 19 over 3, and y is 50 upon 27. Given that y is equal to the square root of 2 plus 2x squared, show that y times dy by dx minus 2x is equal to 0. So of course the first thing we need to do is find dy by dx. So dy by dx, we're going to rewrite this the y as 2 plus 2x squared. 2 plus 2x squared to the power of half, and I apply the chain rule. So it's half into 2 plus 2x squared. Subtract 1 from the power. Half minus 1, that's minus half. And I differentiate what's in the bracket. We end up with 4x. So this differentiated, so this will end up become, so let me rewrite. So 2 into the 4x, the 2 into the 4x I get 2, so I'll have 2x up here. And then using indices, this can be rewritten as the square root of 2 plus 2x squared. Alright, indices, make it the denominator, so the power becomes half, which is root 2 plus 2x squared. Alright, now if we should multiply, so let's look at the left hand side. This proof. So this proves the left hand side. This proof here. The left hand side is y, and y is the square root of 2 plus 2x squared times dy by dx, which is 2x upon the square root of 2 plus 2x squared minus 2x. Let's write that out. Now root 2 plus 2x squared into itself, that's 1. So we end up with 2x minus 2x, which is equal to 0, which is what the right hand side is. Therefore, it's proven. Again, we are asked to show the second derivative minus 4 upon y cubed is equal to 0. So we need to find the second derivative. And we'll find the second derivative by differentiating the first derivative. Now recall the first derivative we have here. The first derivative was 2x upon root 2 plus 2x squared. Let me just rewrite it. It was 2x upon root 2 plus 2x squared. So that was the first derivative. So let's differentiate this and see what we end up with. Alright, so using the quotient rule, differentiate the numerator, we end up with 2 times 2 plus 2x squared to the power of half minus, and now we keep the 2x and differentiate the denominator. We end up with half times 2 plus 2x squared, subtract 1 from the power, with minus half, differentiate what's in the bracket, we'll get 4x, so that's a chain rule application there, all upon the denominator square, which is 2 plus 2x squared, which is 2 plus 2x squared. Now, we can divide each term by 2 plus 2x squared, so we end up with, well, let's not do that. Yes, so I divide each term by 2 plus 2x squared. So 2 plus 2x squared divided by to the power half, divide by 2 plus 2x squared. Of course, you subtract 1 from the power, so we end up with 2 plus 2x squared to the power of half minus 1, which is minus a half. Minus, and then half times 2, that's 2. So we end up with 4x squared outside here. So 4x squared and then 2 plus 2x squared to the minus half, divided by 2 plus 2x squared. Again, we subtract 1 from the power, so we end up with 2 plus 2x squared minus 3 over 2. So it goes minus half minus 1. Now we can try to get a common denominator. Let's write it as a fraction. Now this is 2 upon the square root of 2 plus 2x squared minus 4x squared upon 2 with the root 2 plus 2x squared to the power of 3. Now to simplify, to make the one common denominator, we can multiply this numerator and denominator by 2 plus 2x squared. Alright, so 2 times 2 plus 2x squared upon the square root of 2 plus 2x squared times 2 plus 2x squared, and the fraction will remain equivalent, minus 4x squared upon, and this would be the same denominator, root 2 plus 2x squared all to the power of 3. Now the denominator is the same, so we can, the denominator is the same, so of course we can make the common denominator be root 2 plus 2x squared all cube, and then what we have here now, 4 plus 4x squared minus 4x squared, which will this is equal to 4 upon the square root of 2 plus 2x squared. Now recognize that the square root, the denominator there, recognize that the denominator is actually y cubed, because remember y is the square root of 2 plus 2x squared, so the denominator is actually y cubed. And if you subtract 4 over y cubed from this, you can put 0. Alright, so therefore dy by dx, second derivative upon dx squared is equal to 4 over y cubed, which is in essence, technically that's what we're asked to, that's what you're asked to prove. Now therefore in part 2, d2 y by dx squared is equal to, it was 4 upon y cubed, so it's 4 upon 2 plus 2x squared all cube. Now if x is equal to 0, this will become 4 upon the square root, 4 divided by root 2 all cube, which is equal to, now 4 is 2 to the power of 2, and divide by root 2. Root 2 is 2 to the power of 3 over 2. So you know we subtract powers, indices. So 2 and 2 minus 3 over 2, that's half. So it's just root 2. So question 6. So I'm going to do a little sketch here. 1, 2, 3, 4. 1, 2, 3, 4. So P is a point 0,1, which is approximately there. Q is a point 3,3, which is approximately there. And R is a point 4,2, which is approximately there. Alright, so that triangle PQR using a ruler, joining them would be something resembling that. Alright, determine the equation of each of the following: PQ, QR, and PR. So the equation, of course, you need the gradient. Let's deal with PQ first. So for PQ, gradient of PQ is y2 minus y1. So using P and Q, remember P was 0,1, Q was 3,3. So using P and Q, so x, y, so y x, y2 minus y1, so 3 minus 1 upon 3 minus 0, which is 2/3. Alright, so to find the value of c, using y equal mx plus c. Using y equal mx plus c. Of course, so PQ, so I'm going to substitute 0,1. So y is 1, m is 2/3, x is 0, plus c, so c is 1. So therefore for PQ, equation for PQ, this is a PQ, y equal mx plus c, so is y equal 2/3 x plus 1. So for QR now, for QR, the gradient of QR is which was m, so gradient of QR is QR using Q and R. Remember, R was a point 42. So gradient for QR, 3 minus 2 y minus y upon 3 minus 4. So it's 1 upon minus 1, so that's minus 1. So y equal mx plus c, and this is to find the value of c now. To find the value of c, we use 3. So x is 3, y is 3. M is minus 1, right? So transpose, so 6, so c is 6, so therefore equation of QR is y equal mx, so that's negative x plus c, which is 6. And now for PR, gradient of PR, using 4, 2, and 0, 1. I'm using 4, 2, and 0, 1. So 2 minus 1. So 4, 2. And 0, 1. So 2 minus 1 upon 4 minus 0. So the gradient is a quarter. And then you use y equal mx plus c to find the value of c. So we end up with using 0, 1, m use 0, 1. X would be, y would be 1, mx would be 0. So c would be 1. So therefore, equation of PR, y equal mx, so y equal to a quarter x plus 1. Hence, use integration to determine the area of triangle PQR. So area of triangle PQR, so we integrate all 3 lines. Let's remind ourselves what the equations were. So you'll recall that integration gives you area under the graph. So if you integrate PQ, you will get all of this area. Integrate PQ between 0 and 3, right? So integrate PQ between 0 and 3, you end up all of this area below the line. If you integrate QR between, what are the x, y values, 3 and 4, you end up with all of this area. So PQ, all of this area, QR, all of this area. And of course, to get the area of the triangle, we can subtract the area of PR. The area of PR will be everything under the triangle here, so we can minus the integral of PR. And what were the x values? The x values would have been 0 and 4. So let's set that up below. Let's set it up down below. So of course we end up with that. So equation of PQ, equation of QR, equation of PR. Let's do the calculation. So differentiate first term 2/3 x, we get 2/3 x squared upon 2. Integrate x, integrate 1, we get x, and that's between 3 and 0, plus integrate minus x, we get minus x squared upon 2. Integrate 6, we get 6x, and that's between 4 and 3. And the final integral, integrate a quarter x, we get x squared upon 8. Integrate 1, we get x, and that's between 4 and 0. Now we can make our substitutions. Alright, so by 2 into 2. So this is x squared upon 3. So 3 squared, that's 9. 9 divided by 3, that's 3. Plus x plus 3. Alright. Plus, substitute 4. So we have negative 4 squared, that's negative 16 divided by 2. That's negative 8. Plus 6 times 4, that's 24. Minus, we substitute 3 now. We get minus 3 squared. That's minus 9 upon 2 plus 6 times 3, that's 18. And the final one, we substitute 4. 4 squared 16. 16 divided by 8 is 2 plus 4. So this is 3 plus 3, that's 6. Negative 8 plus 24, that's positive 16. And here this is positive 9 over 2, so it's positive 4.5. This is minus 18, that's minus 6. So this becomes 6 and 16, that's 22. 22 plus 4, that's 26. Take away 6, that's 20. Actually, it's actually 22 plus 4, so it's 26.5. Take away 6, so it's 20.5. Yeah, so it's actually 2.5 square units. For part B, so we have a differential equation there, so we can transpose. So we have dv by dt is equal to minus v upon 2.5, which means that transpose here, so we have 2.5 times dv is minus v dt, so we can divide both sides by 2.5v. So we end up with dv upon v is equal to minus dt upon 2.5. And so this becomes log v equal to, so integrate, by the way, I'm integrating both sides, right? Minus 1 upon 2.5 t plus c. Now of course 1 divided by 2.5, that's 0.4, so 0.4 t minus 0.4 t plus c. Now v equal to 25 when t is 0, so ln 25 is equal to c. So c is log 25, so which means that ln v equal to minus 0.4 t plus ln 25. Can do some transposing here. This would mean that ln v minus ln 25 is equal to minus 0.4 t, and we can combine these logs. So ln v upon 25 is equal to minus 0.4 t which means that v upon 25 is equal to e, my ln is base e, right? So minus 0.4 t, and if you multiply both sides by 25, if you times both sides by 25, it means that then v is equal to 25 e to the minus 0.4 t. And 6c, the final section, given that the integral of 3fx plus g of x equal to 5 and 5fx minus 2g of x equal to 1, determine these values. Now, okay, let's rewrite. So the first one, let's rewrite this one. The first one here, let's rewrite. So we can rewrite the first one is the integral between 3 and minus 1, 3fx. So this 3 here can come outside, right? Plus integral. So we separate g of x equal to 5. Alright, and the other one, this one, integral, we can factor out the 5, so integral of 5 between 3 and minus 1 f of x minus 2 integral of g of x between the same limits is equal to 1. Of course, I'm going to times the top one by 2 and the other one by 1. So what we end up with is 6 times the integral between 3 and minus 1 f of x plus 2 times the integral of 3 and minus 1 g of x is equal to 10, and times 1, nothing changes here. And we can add, so we can add these two equations. Alright, if we add, we end up with 11 x, and these will cancel, right? So equal to 10 plus 1, 11. Divide both sides by 11. If we divide both sides by 11, we end up with, and of course dx, of course, 11 divided by itself is 1. Alright, and of course we can always substitute it into any one of these equations to get the value of the integral of the g of x. Now, can use equation 1 here. Notice that we know the integral of f of x between the limits is 1, so we can sub it into this. We end up with, let me just, now we just found this to be 1, so 3 times this will be 3 times 1, right? So it will be 3 plus the integral equal to 5. If you subtract 3 from both sides, then the integral of g of x with respect to x, of course, is 5 minus 3, which is 2. And that's our solution. So the integral of g is 2, the integral of f is positive 1.